Here's a solution to problem 11.45 in the book, which I had suggested that you'd try. It reads ethanol, whose formula is C2H5OH, melts at negative 114 degrees Celsius and boils at 78 degrees Celsius. The enthalpy of fusion of ethanol is 5.02 kilojoules per mole, and its enthalpy of vaporization is 38.56 kilojoules per mole. The specific heats of solid and liquid ethanol are 0.97 joules per gram Kelvin and 2.3 joules per gram Kelvin, respectively. So there were two parts. At part A, how much heat is required to convert 42 grams of ethanol at 35 degrees Celsius to the vapor phase at 98 degrees Celsius? And B, how much heat is required to convert the same amount of ethanol at negative 155 degrees Celsius to the vapor phase at 78 degrees Celsius? I just want to quickly point out how each of these ends. In each case, you're taking it to 78 degrees, which is the boiling point, and then you are boiling it because it says you're converting it to the vapor phase. You do not then go on and heat the vapor at any point. But in each case, A and B, you take it to the boiling point and then you boil it. So I just sort of cataloged all the information they gave us. The melting point, minus 114, boiling point 78, heat of fusion 5.02, heat of vaporization 38.56, specific heat of the solid 0.97, of the liquid 2.3. And then the last thing you have to do for this problem is to take that quantity that they give you, 42 grams, and convert it to moles. The molar mass of ethanol is 46.07, and so you get 0.912 moles. Okay, the calculations. A is asking us to heat the liquid from 35 degrees Celsius to 78 degrees Celsius and then boil it at 78 degrees Celsius. So to heat it from 35 to 78 is an MCAT. The mass is 42. Specific heat of the liquid 2.3. The delta T from 35 to 78 is 43 degrees Celsius. By the way, note that when you're talking about changes in temperature, then degrees Celsius and kelvins are the same, so we can use these units interchangeably. So for that heating of the liquid, you get 4,150 joules, my bad, which is equal to 4.15 kilojoules. For the boiling at 78 degrees of 0.914 moles, you get 35.17 kilojoules. When you add those two numbers together, you get 39.32 kilojoules. The answer in the back of the book rounds that to 39.3. Part B, it asks you to go from same amount from negative 55 to the vapor phase, negative 155 to the vapor phase at 78. So that means I'm going to heat the solid from negative 155 to negative 114. I'm going to then melt the solid. Then I'm going to heat the liquid from negative 114 to 78. And then I'm going to boil the liquid at 78. So I grouped together my two MCATs. So for heating the solid, 42 grams times 0.97, which is the specific heat of the solid, times 41 degrees Celsius, which is the change from negative 155 to negative 114. That gives me 1,670 joules, or 1.67 kilojoules. To heat the liquid from negative 114 to 78, that's 42 grams times the specific heat of the liquid, 2.3, times the temperature change from negative 114 to 78 is 192 degrees. That gives me 18,550 joules, which is 18.55 kilojoules. I then am doing my phase changes. 0.912 moles times 5.02 kilojoules per mole, which is the heat of vaporization, gives me 4.58 kilojoules. 0.912 moles times 38.56, which is the heat of vaporization. I hope I said fusion back here. Heat of vaporization gives me 35.17 kilojoules. When I add those up, I get 59.97. In the back of the book, your textbook rounds that to 60 kilojoules. Okay, if you have any questions, you can just reach out to me. Thanks.